Hi everyone and welcome to Deep Learning with Python course.
To define deep learning and understand the difference between deep learning's learned features are easy to adapt and fast to learn. Let's look at a concrete example of a neural network that uses Python library keras. When fed an image input, this model returns the values of the layer activations in the original image or model. Another popular and powerful way to associate a vector with a word is the use of dense word vectors. The functional API can be used to build models that have multiple inputs. So that's what deep learning is. Technically, a multi-stage way to learn data representation.
I am Ron Ligdano, a research scientist and a PhD candidate in medical image processing, focusing on the use of deep machine learning based here in France. This course is for anyone who wishes to explore deep learning from scratch or broaden their understanding of deep learning.
Deep learning is a subfield of machine learning to represent data in a learning pattern. Deep learning's learned features are easy to adapt and fast to learn. In this topic, we'll review one basic strategy to tackle the dog and cat classification problem. This dataset contains 25,000 images of dogs and 12,500 cats. After downloading and uncompressing it, you will create a new dataset containing three subsets. Word embeddings are low-dimensional floating point vectors and are learned from data. The simplest way to associate a dense vector with a word is to choose the vector at random. For instance, the words accurate and exact may end up with completely different embeddings. TensorBoard is a browser-based visualization tool that comes packaged with TensorFlow. The key purpose of TensorBoard is to help you visually monitor everything that goes on inside your model during training. Let's launch the training with a TensorBoard callback instance. At this point, we can launch the TensorBoard server from the command line, instructing it to read the logs the callbacks is currently writing. Deep Dream is an artistic image modification technique that uses the representation learned by convolutional neural networks. For each successive scale, from the smallest to the largest, we can run gradient ascent to maximize the loss we previously defined at that scale. After each gradient run, we upscale the resulting image by 40%.
With creative applications of deep learning, deep networks go beyond annotating existing content and start generating their own.